Hello everyone. Let us solve another question. As we already know, there are three methods to solve a question on linear equation with two variables. That is by equating the coefficient, by substitution, and by cross multiplication. So if we look at this question, this is the first equation and this is the second equation. First thing is very important to understand that the equation has to be in the format of a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. So if in case we discuss about these two equations, it is clear that the value of a1 is 1 as the coefficient of x is 1 in the first equation. The value of b1 is 2 as the coefficient of y is 2 in the first equation and the value of constant is 4. While if we look at the second equation, the value of a2 is 2, the value of b2 is 4 and the value of c2 is 7. Now we apply the first method, that multiplying equating the coefficient of these two equations. We know that if we multiply the first equation by 2, then the coefficient of both the x will come out to be equal. So multiplying the first equation by 2, first equation comes out to be 2x plus 4y is equals to 8, and second equation is already 2x plus 4y is equals to 7. Now we have to see that if the value of 2x plus 4y is 8, then it can never be 7 whatever the value of x and y are there. That means if we represent it in the graphical format, if the value of x comes out to be something like this, the graphical representation of first equation is this, then the graphical representation of second equation will be something like this, and they must be parallel to each other. If we solve it through algebra and cancel it out, then as soon as the value of x being cancelled, the value of y also cancelled automatically, but the constant will not cancel themselves. If in case the second equation is also equal to 8, then the constant are also to be cancelled. So what we are analyzing from this is that whenever the coefficient of x in the first equation and the coefficient of x in the second equation, they have a specific ratio. Like in this case it is 1 and 2, so the ratio becomes 1:2. The coefficient of y in both the equation is also having a specific ratio. If the ratio of the coefficient of x and the ratio of the coefficient of y are both equal, that means as soon as the x cancels out, the y will also cancel out on its own automatically. So this is the possibility that the two equations, the value of x and y cannot be calculated. Now this can be equal to c1 upon c2. If in case we take the second equation, the value is 8, then this is equals to c1 upon c2, and this may be not equal to c1 upon c2 as in the existing case. So there are two cases. In one case, the constant value, the ratio of the constant value is also equal to the ratio of the coefficients of x and coefficients of y. In second case, the ratio of the constant value are not equal to the ratio of the coefficient of x and coefficient of y. If this is the first case, that means both the lines are same, one over the other. First line is this and the second line is also same over this. It means at every point the coordinates are same. Or we can say in this case they are infinite solutions. While in this case the two lines are parallel to each other, and when the two lines are parallel to each other, that means there is no solution possible, or for any value of x and y both the equation can never satisfy. While if the ratio of coefficients of x and y are not equal, that means definitely the x can be cancelled out by x and in that case y will not be cancelled out and we can find out the value of y. In this case only there is a unique solution. And for the two straight lines or for the two linear equation, it is not possible to have two solutions, because if they cancel at this point, then on the plus positive infinity towards the negative infinity, they will not cancel. So there are three solutions possible: either the unique solution, or when they are parallel to each other, no solution, or when they are one over the other and infinite solution. So these are the three cases through which by looking at the equation we can find out whether we have a unique solution or infinite solution, or we don't have any solution for these two linear equations. Thank you.